very short intro. So Franco and Yadu are working on well, Yadu for Intrinsic. You are a consultant, right? Working for Intrinsic. I'll let you give you guys more context, and are doing some key work on the alternate RMW, right? So, which I guess what you will be sharing. So I'll let you do the full intro. The floor is yours. Best of luck with the presentation. Have fun, more importantly, right?
All right, inshallah. Thanks a lot for the introduction. Um, so hello everyone. Thanks all for joining in this occasion. I'm glad to be presenting along with Yadu about some work that's been going on for several months now. This works. This work lives within the ROS2 ecosystem and is focused on a new implementation of the ROS middleware. Here it is. Okay, so who are we? My name is Franco Cipollone. I work at Ecumen, and for the last couple of quarters, I've been working as a ROS developer in this effort, along with other people from the ROS team. The second half of the talk will be presented by Yadu. He's also from Intrinsic. He's from Intrinsic. Yadu, I'm not sure if you want to present yourself. All right, Yadu has been acting as ROS boss for Iron distribution and has been a crucial contributor to this new development. So what are we gonna do today? We are gonna be talking a little bit about the ROS middleware just to understand the context of this effort. After that, and more related to the investigation process, we are gonna dive into the requirements that we gather for this new development. Later on a general comparison among middleware options, and finally, we will comment about the current status and future work of the new ROS middleware implementation, which is called RMW Zeno. You can imagine why that name. So let's start with the ROS middleware. For the sake of the presentation, I will assume we all know a little bit about what ROS is, just at a general level. If this is the first time you heard about ROS, then I might resume it by saying that ROS is the most widely used open source development kit for robotics, and it's definitely a tool worth to be checked out if you haven't already. So, regarding the ROS2 architecture, oh yeah, are you seeing? Oh, sorry, some issues with my browser. All right, so regarding the ROS2 architecture, it is based around abstracted communication, which provides a convenient modular interface for developers. Starting from the top, you have your ROS application that is built on top of ROS client library. For example, the RCL CPP is the CPP API of the ROS client library. Same thing for the Pythons and so on. Then that is built on top of what we call the RMW or ROS middleware layer, which is basically an abstraction that interfaces with the actual middleware used for communication. The RMW API allows you to plug and play different implementations. The most commonly used middlewares here are FastDDS and CycloneDDS. However, there are other implementations relying on either or other middlewares. Worth noting that this API allows this layer to be swappable with other implementations. You can use FastDDS, for example, and then switch to CycloneDDS, or even switch to a custom implementation. In fact, this abstraction is what led us to dive into developing a new RMW implementation, in this case, using Zenoh under the hood instead of DDS. So, the reasons we embark on developing a new alternative middleware are related first to the fact that even though the RMW interface is meant to be generic, you might find that it's a bit linked to the DDS implementations, and this probably makes sense as all tier 1 official implementations available are DDS. Therefore, we expect that with a new non-DDS RMW implementation, we will be able, probably in the long term, to make the RMW interface even more generic. Another motivation for this alternative middleware was that when using DDS, even though it works for most applications, it generally requires some careful tuning to match your use case. and this makes ROS2 probably not being as pleasant as out-of-the-box experience. For example, you might find some failures from UDP multicast in DDS, some discovery failures due to scaling issues of UDP multicast. The multicast service isn't always allowing routers or large Wi-Fi networks. Also, difficulties transferring large payloads. This is typically problematic in Wi-Fi networks where the connection might be unreliable. So, as a summary, the various DDS implementations have many configuration points. However, it can be overwhelming for users, mainly for new users, to figure out which tuning parameters they need and for which reason. So after identifying the motivation, we proceeded to define the requirements for this new ROS middleware implementation, and by extent to the underlying middleware to be used. So we gather requirements via several sources. There are some known ROS2 use cases that we use as baseline, also via targeted interviews with key stakeholders in the ROS community who share many insights from their use case. And we also sent out a survey to the ROS2 community. We got almost 200 responses, which helped a lot to understand the user and identify requirements. Here, some insight from the survey. Here, we are showing first some demographic information obtained from the survey regarding organization size. The half of the respondents were from a small business organization, while the rest refers to large business, academia, and research organizations. Regarding the scale of the robotics application in terms of number of robots, we can say that the half of the respondents have small fleets of robots, less than 10 robots or so. However, applications with 10 to 100 robots are also significant, according to this survey. Regarding the typical number of topics in the network for the application, is dominated by a range between 20 and 200 topics. Continuing a little bit with the information from the survey, regarding container technologies, Docker and Pullman were indicated for the majority of the respondents as the technology being used. And regarding network topologies, we can see that there's a common use of localhost only, Wi-Fi, cellular network, VPNs topology that probably stand out from the others. All this information helped us a lot to understand all sorts of requirements before actually diving into analysis of the middleware options and in the implementations. And now I'd like to turn things over to Yadu, who will continue with the requirements.
All right, thank you, Franco. Good morning, good evening, everyone. My name is Yadu, software engineer at Intrinsic. I'm happy to walk us through the rest of this presentation. So as Franco mentioned, over the development of ROS2 over the past 8 years, we've unearthed certain issues that users are facing with regards to DDS and discovery. And this sort of prompted us to go down this path of identifying the next middleware to use. We wanted to be very systematic about this study that we perform. So our goal is to have a list of middlewares we want to evaluate, but also define certain requirements to evaluate them against. And as Franco mentioned, we had 3 different sources for getting these requirements. Internally, we know what ROS2 needs to be able to do, but we also spoke to several key stakeholders and maintainers of large popular repositories within ROS2. But more importantly, we had this user survey that helped us understand better of what sort of applications are more important to users. So all of that information was synthesized into these requirements that you see here. And the level that we use to quantify or qualify these requirements follow RFC 2119, and it just tells us certain keywords or standardized keywords which we can use to evaluate the level of a requirement. So here we're using must for something that is important, is extremely important. We have should for something that's recommended, and may for something that's optional here. So if we look at some of the must requirements, pub sub is at the top of our list, and that's something that's critical for a lot of our users. It's the bread and butter of ROS2. RPC, or remote procedure calls, has been assigned a level of May. And that's really because we see RPCs as something that we can also implement with a pair of pub subs. So at the bread and butter, we need pub sub to work. ROS2 is meant to go into production environments, so security is extremely important. And we classify security or break it down into 3 different categories: encryption, authentication, access control. We also want to be able to handle reconnecting to the network, or handling network disconnectivities, or handling other sorts of bandwidth issues on the network itself. And that's extremely important to us, because robots move in various environments where the network connectivity really varies over time. Or you could have robots that go into elevators or go between rooms, and then they might intermittently lose connectivity, and that shouldn't, bring down the entire system. There should be some sort of resilience to connect back to the network. So that's something that's very important to us. We talked about discovery quite a bit as some of the issues we face with DDS. We have built-in discovery at a should level here, because we feel like this is something that we can also implement. It's not important that the middleware provides a full discovery service out of the box, but this is something that we should be able to implement, so that we can introspect what's going on with the different nodes in our graph, understand who's publishing what information, and also just get some statistics in general. So I think there's a lot more details on each of these requirements within our report. So I'll save us the trouble of going through each one of these items in the list. There's a link on top. Please feel free to go check it out. There should be detailed notes on each of these requirements. Let's go to the next slide. So we took all those requirements, and then we also came up with a list of middlewares we want to evaluate. And these list of middlewares come from that user survey we conducted, but also some insights that we have into the industry, and as well as some other protocols that we wanted to try. So as you can see here, we really evaluated a good variety of protocols that are written in different languages or based on different frameworks. But overall, the goal was to take these middlewares, take the requirements, and then come up with a list, come up with a table, a matrix table, to evaluate each of these middlewares against the requirements. And that's really what we have here in this next slide. So again, it's a super dense table, and I don't want to take up the time here to go into how we did this evaluation or how we scored each one of these middlewares. But the key idea is that this report is publicly available. Please click on that link later on and check out this table. You should be able to see exactly how we scored each of these middlewares. But I just want to highlight right now of how Zenoh did across all these other middlewares. As you can see in the slide that's highlighted, the column in red, that's the entry for Zenoh. And you can see a lot more green than red. So that should be an immediate indicator that Zenoh fared really well against our evaluations. The boxes or the rows for which we had to score it, that you see in yellow here, represent certain features that don't exist today, but are committed on the roadmap for the middleware. So in this case for Zenoh, things like shared memory, or perhaps access control with security is not available at the time we did this evaluation, but we know that it will be ready by the time we need this to be a stable middleware solution. So across all of these different middlewares that we evaluated, Zenoh definitely stood out to us the most. So in the next slide, we'll just talk about some of the highlights in comparison to some of these other middlewares. So Zenoh by far meets most of our requirements. And like I mentioned, what it doesn't meet right now, there is a commitment from the ZettaScale team to have these features in for us. If we look at some of the other top contenders that came out from this evaluation, TCP ROS was the second best performing middleware. And this TCP ROS is basically the custom middleware that we wrote for ROS1. And you can imagine how popular ROS1 is. It works great under various situations. The only downside is that it's kind of brokered. It requires a central ROS core to be running to be able to forward discovery information across different participants in the network. And that became a central point of failure, which was what the prime motivation for relying on a peer-to-peer topology with ROS2 was. So there's no surprise that we saw TCP ROS here. Some of the other contenders that we saw were MQTT, which does meet a lot of our requirements, and it's used extensively in the IoT world. But the key limitation for us, on top of being brokered, was the fact that it has limitations on the payload size, or the messages that we can serialize and send over the transport layer. So that was a big limitation for us. ZeroMQ is also popular, But and as a matter of fact, we use it in Gazebo. But ZeroMQ is really a toolbox or a set of APIs that you can use to write your own middleware. And for this purpose, we don't want to spend too much time writing a middleware that fits all our requirements. Rather, we want to see what already exists, what's mature out there, and apply it for our applications. We also went through OPC-UA and Kafka. OPC-UA, while it meets some of the requirements, the architecture doesn't really support some of the features that we're looking for. It doesn't do any sort of discovery, and it's also, in a way, centralized. Finally, Kafka was interesting, but it seemed way too complex to configure for a beginner user, or effectively configure for it to work with multiple systems at the same time. I do want to highlight that all this evaluation that we performed was pretty qualitative. We left performance analysis out of the scope of this evaluation, as we found that in the past, every time we evaluate some of these middlewares, it's really subjective to how well the middleware is tuned. So Franco mentioned there's all sorts of parameters with several middlewares that you can configure. So more or less, you can get the same gross performance when you tune each of these middlewares. But what we're really looking for here is that out-of-the-box simplicity and also friendliness for new users. It was nice to see that from the results of the user survey, if we rank what were the popular middleware suggestions from the community, Zeno was #1. So it's great to see that we kind of independently arrived at this conclusion, both from our systematic study as well as a popular vote from the community, that Zenoh should be the next middleware that we rely on for ROS2. All right, having said that, I'd like to spend a couple of minutes giving an update on the status of our RMW Zeno package. So RMW Zeno is the ROS2 middleware package that we're writing that's based on Zenoh. And it's a C++ package that relies on the Zenoh C bindings to implement certain interfaces defined in the RMW package. So as Franco mentioned, RMW is that API layer which you use to derive or implement your middleware-specific functions. And then this is something that's swappable at runtime or compile time in ROS2. So we want to make it such that users can just change a single environment variable that says, use Zenoh as my middleware, and then boom, all the nodes are communicating over Zenoh. And that's what this package does here. So our goal is to have this have the source version of this released by Jazzy Jalisco. So that's coming out in May 2024. And right now, a quick progress update on this is we have PubSub working in certain graph introspection features. So we're able to kind of query the ROS graph to know who are the publishers, subscribers, what topics are being published, what nodes exist, etc. And we're currently working on implementing support for clients and services. Another feature that we're also working on is supporting a variety of quality of service settings. And that's something that will hopefully come in really soon. Cool. I'd also like to talk a bit about the topology that we've adopted here for RMW Zeno. So the great part about Zeno is it works in so many different topologies and it's different network configurations. We chose something that we felt would work across various robotics use cases and is simple enough for people to use out of the box or with minimal configuration if needed. So we're relying on the ZenoD router to act as the broker purely just for discovery information. So this is a service or a daemon that's running behind the scenes, and it's just forwarding discovery packets around to different nodes. So the way it works is every node sort of publishes or advertises itself over UDP unicast. So there's no UDP multicast enabled anywhere that was causing all the nasty discovery traffic issues before. So UDP unicast is used to just broadcast discovery information from a peer to the router directly. And anytime a new participant joins the router, it's given the information of the previously connected peers from the router. But the payload itself is transmitted peer-to-peer. So this is not going via the router. The router is not acting as a broker for the information. So this is going to make transport pretty efficient as well. So Zenoh APIs, I should clarify that the Zenoh session did not allow us to directly introspect the graph of the peers. So we're not able to query using any APIs to know what nodes exist, what publishers, subscribers exist. but we were able to implement something using the liveliness token feature from Zenoh. At this slide, I just wanted to highlight some of the improvements or additions that came into the Zenoh C API as a extension of this work that we've been doing. So our team has been in close contact with the ZettaScale team, and we've been working together on this RMW development. And along the way, we've identified certain features that would be nice to have in the Zenoh C API that already exist in the Zenoh Rust API, for example. And I just wanted to highlight that two such important features we had ported over to Zenoh C were liveliness token support, as well as this publication cache and querying subscription functionality. And the latter is really going to allow us to support transient local durability for quality of service. So for people who don't know that, you may have a publisher that published your data once, and then you may have a subscription that joins the graph at some point later in time. So this subscription needs to have a way to also get this information in that was published once. And that's really what this feature is going to help us with. So in conclusion, we feel that DDS is here to stay, but we strongly think that an alternative middleware protocol is beneficial to the entire community. And from the results of our study, which are both community-driven, but also driven based on 8 years of experience of working with ROS2, we feel that Zenoh is definitely the preferred choice for this alternative middleware, given how well it handles discovery, as well as transferring payloads over a variety of network topologies. I'll just conclude by saying, please look out for our source installable version to be available by May next year. And we hope to have a lot more improvements and code quality fixes and bug fixes and much more stable code available for everyone by KTurtle in May 2025. Thanks again for ZettaScale for organizing this. It's been a great process so far. Looking forward to wrapping up this work. And I'm just excited to be here. You can tell by the shirt.
Yeah, thank you guys. And I know it has been a journey. It was been, as you know, we were proud and surprised and thrilled and scared at the same time, right? Because it's a lot of pressure. I think lots of emotion were flowing, but it has been great working together. We are really impressed by how quickly you guys are progressing. And so, look forward to more of this. So thanks again for the presentation. Let me thank you all. Yeah, thank you guys. So let's bring up Stephen, which is coming up next. So before I let you guys go, hello Stephen, how are you? So we had now Northern America, right? Stephen from GM connecting out of Canada. And so thank you again, Yadu and Franco. I'll let you follow up with question online on social media, and I'll catch you up later. Thank you guys again. Keep up with the great work. Thank you. Bye.